Hello and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from an IoT Builder perspective. This is December 7th now, and it is episode 12 of our weekly live stream. Let's see, today we have a special guest, Natali Tshuva, who is the co-founder and CEO at Sternum IoT. My name is Dan Gross. I'm a senior developer advocate for AWS IoT and FreeRTOS. I am joined by my colleagues and co-hosts today. Let's see, Alina and Nenad. See who we have on the line here. I think Alina is just joining. Hey, Alina, how are you?
Hi Dan. Yeah, like always, happy to be here. Took a little time to connect, but now everything is fine. Hi Natalie.
Fantastic.
Hello, Dan, Alina. Great to be here.
Hi, Natali. Yeah, it's great to have you on the show. Thanks so much for joining. Just as a few people assemble here, maybe you could just introduce yourself briefly. What's your role at Sternum?
Sure. So my role at Sternum is a CEO, but I'm what you may call a tech CEO, as I come from an extensive engineering background.
Oh, that's fantastic. Yeah, as I understand, you you have quite a unique background and where you come from in terms of the security space. I understand you come from the intelligence community. Is that right?
Yeah, that's right. Not sure how much special it is here in Israel. We have to go to the army, and some of us go to Unit A 200, which was my path as well. I
Mm-hmm.
did my undergrad in computer science when I was 14, and that basically paved the way to Unit A 200. And the rest is history because advanced cybersecurity and vulnerability exploitation, reverse engineering, and lots of handling with embedded devices was involved. So yeah, intelligence communities where I come from, together with what you may call an embedded experience.
I see. Yeah. So I think generally from the IoT and IT perspective, that is kind of a unique background. Um, but so you're joining us from Tel Aviv. Is that where Sternum is based?
Yes, Stern is based in Tel Aviv with offices in Boston and Europe.
Okay. Fantastic. Fantastic. So, so what does Sternum do? What's the company charter, and what types of things are you accomplishing in the IoT space?
Yeah, so in very short sentences, Sternum helps device manufacturers or builders, as you mentioned, to secure and monitor their IoT devices. In more than one line, I think all of us as builders understand the gaps that we have as we build software and devices, how hard it is to debug issues, how hard it is to gain observability and insights. What application developers has and having for years now, which is observability, cloud monitoring, application profiling. Embedded engineers don't have. You mentioned FreeRTOS. Real-time operating system has almost no security solutions or observability solutions. This is the challenge that Sternum set out to solve, and we bring a very simple, elegant platform that developers can apply to gain runtime protection against cyber threats and runtime observability to allow faster resolution of issues, anomaly detection on software behaviors, and really bring Datadog into embedded systems, including real-time operating systems.
I see. So are those gaps what led you to found Sternum and to take that path?
Absolutely. I think two main things make me and my friends go into that path. The first one was the fact that we were able to hack into any system. In the army, in Celebrite, we were able to hack into Android devices, Linux kernel, iPhone devices. I saw firsthand how I can create exploitation to exploit 0 days in Linux kernel. And it came to us to realize that we are losing as defenders. And I think our practice in embedded systems and how they affect the medical industry, critical infrastructures, and so on, we wanted to create something which flips the power between defenders and attackers, and to create a new kind of security for those systems. That was the first reason. The second reason is that some of us, including our VP R&D, for example, was managing more than 40 embedded systems along their career, and with no visibility into them in the field. And it's absolutely amazing, like the fact that you cannot debug issues, that you cannot have logs in real time that can make sense, that you don't even know how users behave with your products, and how difficult it is to embed tools like that or to use existing tools to gain this observability and insights. We thought that this could be a game changer for the development experience and the entire product lifecycle, and we are very passionate about that.
Yeah. Yeah, that's awfully scary when you when you step back and say, "Oh, I can hack into all of these systems," and we don't have a lot of visibility into, the devices we deploy and in the fleets we manage. Yeah, so tell me a little bit about what the specific platform does, and how you're helping some of your customers and builders really fill those kinds of gaps.
Yeah, so we work with lead companies like Medtronic, NXP, ARM, and some others that I actually cannot disclose. And we help them in two elements. And sorry for talking about two things at the same time all the time. It's just that Sternum really believes that the synergy between observability and data and cybersecurity is very strong. So when you think about our platform, always think about these two components. And from the observability side, and I'm getting a little techie here for a second, our customers are getting an open source SDK. It will be open source soon, but they're getting the source code. And they're using this SDK to collect logs, events, and any kind of data types from their software. We recommend them where to put traces, and they can basically trace any kind of arguments or events. The SDK is then coupled with our cloud platform. In the cloud platform, they have automatic anomaly detection on the events coming from the devices, so we can identify violations in patterns, missing events, missing authentication, abnormal behaviors, crash dumps, memory issues, in our cloud platform, which also provides device statistics, fleet trends, analytics, a way to build custom dashboards, and basically everything engineering and product teams need, not just to monitor their fleet of devices, but also to accelerate time to market, improve quality, and save time and resources on support and debugging. That's one way of how we help our customers, and actually became the centralized platform for managing fleets of embedded devices. The advantage in our approach is that you can apply it the same way for Linux-based devices and any kind of RTOS-based devices. So it's universal, and you can have in one place mobile applications and different device types, and see how they communicate with each other if you have a complex architecture. The other side of the solution is the runtime protection, which is in layman terms being CrowdStrike or Sentinel-1 or antivirus, you can say, for embedded systems. So we can stop threats in real time. We alert you if somebody is trying to hack into your device, and we are capable of preventing 0-day and 1-day exploitations, and by that saving a lot of money on patching, which is a problem in the IoT space, saving a lot
Mm-hmm.
of money over other solutions like static analysis and so on. But yeah, you stopped on patching, and I understand why. This is something that we keep hearing from our customers. Everyone is asking us to patch, and it's difficult. It's cost me money and resources to patch. I'm spending too much time on it. It's hard to get the patch into the field. I'm in this endless loop of vulnerabilities being disclosed, and I have to patch. How can you help me? And Sternum is helping exactly with that, because when you are securing your device natively, embedding security that can act in real time against different vulnerabilities, then even if a new vulnerability pops up, you are not vulnerable because we prevent the exploitation. And that's the biggest innovation of how hard security works compared to other solutions.
Yeah, so it really starts with this SDK and having an embedded kind of code into the device firmware. It sounds like, and in that way, then you can enable all of the observability on the platform side. And now you mentioned patchability. So what's your I'm not familiar with the platform itself, but how do you deal with things like OTA, updating firmware images or doing security patches, that kind of thing? Is that part of the client software as well?
No, it's not part of the platform. You can imagine our platform as an add-on to provide software protections. So
Mm,
CrowdStrike, for example, is not patching your Windows system, right? It is just
right.
securing the system as it operates. We're the same. If you have OTA, then great. We will monitor the process for you. But our platform, it adds integrity verification into the software to prevent software vulnerabilities from being exploited. Let me explain what it means. Many of the vulnerabilities, or if you even take a look at top MITRE 25 most dangerous vulnerabilities, you'll see types of attacks like integer overflow, stack overflow, heap
Mm,
overflow. What Sternum is doing is adding checks into the firmware to make sure that there are no overflows, that there are no violations in the memory, that the integrity of the execution flow is being maintained. And by doing that, we can prevent vulnerabilities from being exploited. We are not adding encryption or OTA, we are not adding functionality into your device. We are just
hmm
securing your existing code and libraries, third-party supply chain, that usually you don't even know what kind of security measures are implemented in them. We make sure that they are protected against various types of exploitation. Now, on top of that, when you also add the observability, then you can monitor also the entire behavior of the device and identify issues in the OTA, devices that didn't receive updates properly, devices that had missing authentication or the certification failed, and many other things that can happen. This is being handled through the observability component. I hope it's
hmm
clear because we have like two components. One of them is deterministic, does not need any cloud connectivity, and protects the software. And the second component is the observability that brings real-time monitoring and detection of different issues.
Yeah, that makes a lot of sense. It's clear to me, the distinction there, and so that's what you refer to as autonomous security and observability, as a platform, right? It's once you set it, then it it stays secure, and then you have this observability function, right?
Yeah, correct. And usually at this stage, people think it sounds like magic, but not in a good way, right? It sounds like magic, and we don't understand how it works.
Right. Like a magic
So
wand. Yeah, not good.
yeah, exactly. No, so here's my step back and say, you know what, this is traditional security. Like we took concepts like RASP, runtime application self-protection, which is very
Hmm.
familiar, EDR, endpoint protection, and we just implemented them in an innovative way to work with less than 1% overhead and to fit embedded systems. We didn't invented a new method. We just applied deterministic security methods to help secure deterministic systems, which is essentially embedded systems.
Mm-hmm. So yeah, so this is this kind of a, I guess, a level on top of like a secure boot or code signing or things of that nature.
Yes, it is a level on top because then when you think about cybersecurity attacks, you need to assume that the proper security controls are inside, right? Apple devices, Android devices, they have secure boot, they have encryption, they have everything. But
Hmm.
NSO and Celebrite and other companies are still able to hack into them, right? The way that they hack into those devices is using software vulnerabilities. Like if you have a simple buffer overflow in the way you parse packet, a Bluetooth packet, then
Hmm.
this is all the attacker needs to bypass your encryption, to bypass authentication, and to bypass secure boot. It doesn't help you against it. This is
Ah,
what you call in-memory attacks or remote code execution. This is how it's being done. And Sternum is a layer of software protection against this kind of threats. It is not secure by design. It's making sure your security by design works properly, that you don't have bugs and mistakes that could affect the security of your system. And of course, you have bugs because everyone have bugs. The numbers talks about 15 vulnerabilities per 1,000 lines of code. So we have code, we have vulnerabilities. Sternum job is to secure your code in real time.
yeah. Okay, that makes a lot of sense. So, in terms of verticals that you know you're working with, and you know your customers are coming from, I see that you're working in the medical industry as well as industrial, you know, Industry 4.0, smart cities. You know, maybe tell us a little bit about some of these verticals and you know, some of these customer use cases that you can share, of course, that are kind of interesting or that you see applicable to what you're doing with Sternum.
Yes, of course. Let me just start and say that at the core, there is no really industry distinction because I think
Mm,
embedded engineers around the globe is dealing with the same issues. And product leaders of device builders are dealing with the same issues. The only difference that we see is with regulation. So we have a customers in the medical space where we help with FDA submissions. We help with post-market surveillance, for example, and had adding risk mitigations and monitoring to the medical devices to make sure that there is proper incident response. So these are the kind of things that we did in the medical space. For example, on a patient monitor that monitors a pacemaker at people homes, which is a very
mm.
special project. Another customer of ours is building a pill to help with gastro issues, basically.
Wow.
They are now got an FDA clearance. We are helping them making sure the device is not hacked and that they have a monitoring system to the device. Another one is actually a neuromodulation device, but the use case itself is less important because observability and security works agnostically to the use case itself. And the SDK allows them to collect any kind of data. So they can define collecting insulin doses or temperature or pressure. They can do that on their own. They don't need Sternum. And this is why I think our platform is very likable by engineers. They can just have printers, routers, video recorders, PLC. Um, Sometimes there are regulations around industrial devices, but that's the main differences that we see.
Yeah. Yeah, it's interesting when you explain it that way. It really does make a lot of sense that really all devices need to be secure, and in the IoT space, there's some level of connectivity, and there's some sense of sending data to a cloud platform, and interacting with that in a connected fashion. So yeah, really, the industry itself becomes maybe less important if you have a robust solution to address those needs, right? That's an interesting perspective. Yeah.
Yeah, and I always like to think about it from the hacker's perspective, right? This is where we came from.
Mm.
Lots of us in the R&D actually came from the other side. And as an hacker, you don't care about the device itself or the industry. Let's take, a look into the last year's vulnerabilities, like Blueburn or Zephyr vulnerabilities in the operating system itself, Ripple 20. All of them was vulnerabilities that affected multiple industries because they all use the same library, and the library has a software vulnerability in it. So hackers don't really need to understand anything about your specific device or industry. They are just exploiting software bugs. And for that, there is no industry specific knowledge that you need. So our security actually works with the same concept. We don't care really about the application logic that you have. We care about securing your software itself against those issues. Does that make
Cool.
sense?
Yeah, yeah, no, that makes a lot of sense. It's really, yeah, it's kind of I would say, in some ways, a unique, a unique positioning, because I think a lot of solutions approach it from a use case perspective, or an industry perspective, and really, it's kind of turning the tables a bit on that and saying, well, look, it's all devices are potentially hackable. So how do we solve that? And that's really great. So what are some of the biggest challenges, I guess, that customers are coming to you with, that you're solving, and maybe that you're still working to solve? Maybe some of the things that you see as really the work ahead.
Yeah, so customers are usually coming to us with my customers require security and I'm not sure what to do. I have vulnerabilities that I need to patch, and it's happened to me 3 times already, and I'm looking for a more sustainable solution. Or I want to see real-time alerts if somebody is trying to attack me, and be protected in real time. And observability is slightly different. It's usually engineers that are looking for better ways to build their software. But that's what we already do. Some of the challenges ahead of us are actually pretty interesting. First, we want to make this solution simpler and more accessible. What I mean by that is that we already have a free license to secure OpenWRT devices. We are planning to release more tools to the industry that will be for free, either for security or for monitoring and observability and anomaly detection. So one of the challenges that we have is to make it so easy and understandable to use, and so we can release it basically to the public. That's
Mm.
one thing that we really want to achieve.
So is that like open
Um,
source, the idea of like open source tools in order to, enable the platform, that kind of thing?
Doesn't necessarily will be open source, especially the security,
Okay.
but some of it will be
Hmm.
for free. So you can just
I see.
download it and use it and test it and evaluate it. And one of the things we released is actually an evaluation platform that allows you to test security just to see if your system has any mitigations. Not if it has vulnerabilities, because every system have vulnerabilities, but if it has any means to protect itself. So we plan to release more of it and just make security more accessible, because I think one of the issues in the industry is that we don't really know how to evaluate security yet.
Hmm.
And I think our mission is to help with that.
Yeah, security does maybe share your thoughts, but security does feel like an afterthought a lot of times when designing systems, or an add-on or something like that. People don't start with security. Do you think that's a problem?
Actually, I don't think it's a problem. And
Hmm.
let me explain. I think if I look at other industries, that's usually the case. You can build software and try to use best practices, and this is what everyone should do. But at the end, when you release a product, this is where you want to put the last layer of security. And think
Hmm.
about, enterprises. They use endpoint protection, they use cloud protection. It's not like AWS servers are not secure, right? But we're still using cloud protection to secure also the hosts, not just our application. Security will
Right.
always be an afterthought. I think that's our DNA. We first want to build our products, and only when it's completed, we can think about security. And this is why I like the sternum approach, because you can apply it at every stage. We just applied it on a 5 years old medical device. Is out there for 5 years, and only now they enabled our runtime protection. And since it's
Hmm.
easy to enable it, then it's okay that it's an afterthought. We just come in, we send you a plugin to your IDE or development environment or workload, and then you just enable it, and we automatically put our defenses into your firmware. So it can be an afterthought, and I think we can't fight it. So we need to actually build solutions that comply with the fact that everyone is doing it as an afterthought.
Hmm. That's great. Yeah, it's never too late for security, right?
Yes, it can be too late, because unfortunately, as long as your devices are connected, they are at risk.
Right, right, right. Okay. So hey, you mentioned OpenWRT. So what kind of support do you have for that? And do you see a lot of deployments using OpenWRT, or um, just kind of curious your thoughts about that?
Yes, so first, our offering for OpenWRT is the layer of prevention against software vulnerabilities, like command injection, heap overflow. So you can easily apply our protections and get alerts on prevented attempts, either 0 days or 1 days. And you can get it for free for up to 3 devices. You don't get any observability or any of our advanced algorithms, but command injections and heap overflows and stack overflows are pretty much, I think, 30–40% of the vulnerabilities in embedded Linux. So it's quite nice, and this is what you get for free. Now you ask if we're seeing a lot of deployments. OpenWRT is mainly used for home routers. And we really want to help people who care about the security of their home router to gain the next gen or the next step of security. And many of our users are home users. Usually, the people who use OpenWRT care about security, so they replace the firmware of their router to use OpenWRT, and now they can
Mm,
just easily apply security layer on top of it. So it was really a way for us to at least help home users protect themselves a little bit better. Obviously, the router is the gateway to everything in your house. So being able to catch the threats or the attacks at the endpoint, at the edge device that is the gateway for everything else is very important.
Okay, yeah, that makes sense. And do you support other specific OSs that you know you can call out?
Of course, just not for free. This is the only one that is for free. But our solution is universal, so essentially every operating system is supported.
Mm,
But to be specific, real-time operating systems like FreeRTOS, Zephyr, Microyom, VxWorks, ThreadX, Seger, they are all supported and we already have deployments on those systems. Also bare metal, like if you don't have an operating system at all.
right.
As long as it is based on ARM. On the Linux side, we support everything, including x86 architecture and all flavors. So, of
Mm,
course, Yocto and OpenWRT and many other distributions are supported.
I see. Okay, well, that's great to hear about FreeRTOS as a proponent of FreeRTOS. I'd like to give a shout out for that. Yeah, so
Sure.
it's something. Is it something that a developer can just experiment with? What's the sort of entry point into using some of the Sternum tools?
Yeah, currently we have two entry points. One of them is the traditional one. Someone from our team will give a call to the product security, product, or VP R&D, and tell them about our solution. And we have a very quick POC or evaluation kits. The second is really an engineer wanting to try it out. And then we can either engage the old-fashioned way, or we can just send this engineer an evaluation kit or the SDK or some of the components for a free trial.
I see. Okay, that's great. That's really great. Um, let's see. I don't want to hog the conversation. Alina or Nenad, any questions for Natalie?
Yeah, I do have a question actually. So, I mean, a little bit of context for my question. For quite a long time, as I was working in professional services, I've worked with telco customers who are trying to integrate their routers with the AWS IoT Core platform. Yeah, so as part of that, I've gained a little bit of experience with OpenWRT systems. So I wanted to ask you, do you work also with ISPs? I mean, are ISPs your customers, or would you say that it's mostly just consumers trying to protect their routers?
So the free layer is mainly home consumers. For ISPs, we have obviously a more advanced package that includes, as I mentioned, the SDK, the anomaly detection, another layer of security that we don't have in the free tier. And yes, we're definitely working with ISPs. We're actually now in a very interesting process with one of the major ones, exactly about what you just mentioned, integrating this kind of solution into the routers through the ISP. So that's very specific and an interesting use case, as you mentioned.
Mhm. That's really interesting. And for the monitoring solution, I'm just curious, is there any fingerprinting algorithm involved in how this data is collected and sent?
I'm not sure what you mean by fingerprinting protocol, but we have a proprietary protocol on how we actually compress the data, encrypt it, and send it to the cloud. And this is part of what makes the Sternum platform special, is that this algorithm is at least 3x more effective than any other that we are familiar with. Fingerprinting is a term that we use actually for the security algorithms, as they fingerprint the way that exploitation work in order to be able to prevent it in real time.
I see. Yeah, I was thinking something more in terms of, when something is not working and there is some sort of crash dump, some binary crash dump, and then using some sort of mapping algorithm to find out, where the problem could lie. And instead of
Oh,
sending that entire core dump, potentially to the cloud, you could send just a key representing the problem.
got
Um,
it. So we have something slightly different but similar. So since we have hooks into memory operations, we are capable of automatically identifying if you have a crash, like what was the overflow and where was it in the memory and which function caused it. Or if you have a memory leak, we're able to show you exactly what memory was leaked and from where. And this is actually the alert that we're sending to the cloud is showing you exactly this information. So when we have this specific information, we can send only that. And this is a very quick resolution from that point on because you have all the information you need. Other than that, other than the memory hooks and our way to automatically understand what went wrong, we don't have a way to map crash dumps specifically, and we try to avoid running a lot of logic on the edge because we don't want to interrupt with any of the performance of the device. So maintaining less than 1% overhead and minimal impact is about moving as much logic as you can to the cloud and only reporting on deterministic things that you know, like the memory leaks I mentioned or the overflows, which caused a
mm.
lot of issue, by the way. Does that make sense?
Yeah, absolutely. This makes total sense. Thank you.
Sure. It was a great question, by the way. We thought about it.
So, so just stepping back a little bit, what keeps you kind of interested in the IoT space? It sounds like you could potentially focus really on just the security aspect, but you're bringing in observability or you're working with connected devices. Um, what keeps you interested in that space? Why is the focus on IoT?
Yeah, let me give you the formal answer and then the story. I think the formal answer is that the IoT space is really interesting to me because it is supposed to be the future, but it is based on the past. And what I mean by that is we are using systems, embedded systems, low resources, old-fashioned techniques to do things, and we are building the future with this old infrastructure. And I think it is a problem because I believe IoT is the future in many aspects, but we have to create a bridge between the past to the future. And to me, if we are able to build the right bridge, then this is a great impact on technology and on our world. And this is why I'm very interested in that, because I think building the right bridge will create a real impact on many industries.
Hmm.
The story behind that is that at some point I was, well, actually from when I was 3 years old, I wanted to be a doctor. And when that didn't happen, I tried to find a way into the medical industry.
Oh.
And this is how I got exposed actually to how IoT in the medical industry really impacting human lives and saving them and improving treatments. And this was like the backstory of how I understood what impact we can do if we build this bridge for embedded systems.
So working on the technology that supports the medical industry.
Yeah. Yeah.
That's excellent. That's excellent. Saving lives through technology.
Yeah, if I'm already in the cyberspace, at least let's do something good with it, I guess.
Yeah. Yeah. And so what types of what are you looking forward to in the IoT space? Like what do you see as a positive outlook on IoT. What sorts of things do you think are very interesting and again keep you excited about IoT?
I think we are about to handle massive amounts of data and data points, and I look forward to seeing how it looks like when everything is connected and analyzed. When we actually have all these industrial devices, infrastructures, railways, medical devices, smart cities, everything really connected and sending data that we can actually process and analyze and gain insight from. I wonder how it will impact cross industry, like how industries will learn from one another because
Mm,
everything is connected. So that's one
mm-hmm,
thing that I'm interested about. The second thing is that I think really for it to accelerate and grow, it has to be secure because customers that are using those devices are getting worried. And if we're able to connect those devices to some SIEM or SOC or security dashboards and show them, how the devices behave in real time and secure them, I think it will make an impact on the adoption of those devices.
mm-hmm. Yeah. Yeah, we do a lot of, instrumentation, and there's lots of dashboards and tools in, cloud infrastructure, for example. You can set up all kinds of watches and things on, your cloud services. But I guess when it comes to the devices and all of the deployments to, all of the uh, things in the real world, we don't have such detailed dashboards in various data points, and that would be massive if we had all of the same kinds of tools available to everything out in the field, right?
Yeah, and imagine everything is centralized, and usually using the cloud providers, you can gain device management and some basic device monitoring, but it's more difficult to gain really granular device level information and run algorithms on that. For
Mm-hmm.
example, collecting a log about the amount of insulin that was injected through the insulin pump, and then having an algorithm that shows you the average amount, the average time of day, if a specific patient is behaving differently with his insulin pump. Those kind of, let's say, granular insights and a flexible way to define them is missing in my opinion.
Mm-hmm. Yeah, yeah. How do you query those types of things, to specific devices or a fleet of devices?
Yes, exactly.
Okay, so what kind of technology do you think is interesting? Maybe up and coming technology, or even old technology, maybe that's underutilized, or you know, that kind of thing. What types of technologies do you think are really interesting in the IoT space?
I think that first, even connecting, via open telemetry, even though it's very hard to apply on embedded systems, but let's assume you do something similar and then connect it to Grafana or Datadog. It's probably not the best use case, but I think this is some existing tools that maybe we can use. Second tools that we should probably use are some built-in defenses that compiler comes with, like
Hmm.
stack canaries, allow them, enable them. Stack canaries to help prevent stack overflows and strip your binaries from debugging information. And, if there are some memory protections enabled, even though they are only protecting against very limited amount of use cases, but if they don't cause a lot of degradation, enable them because it really helps prevent some of the weaknesses that we have.
Mm-hmm. Do you think the Rust language helps with that at all?
I'm not sure it's really applicable to many applications that we see in the
Mm,
field.
Hmm.
So it may be good for some use cases, but I don't see medical devices, written in Rust anytime soon. And
Right.
I think it will help with, not having maybe heap overflow, but just changing the language is not really a solution for security. Applications are written in Java and they still, or Python, and they still have software vulnerabilities. So usually it's nice, but it's not holistic.
Yeah. Yeah, that's a good point. Yeah, that it comes up a lot, is Rust a better language for embedded development? And yeah, it's an interesting point. It's not so much the language, but really really how you use it.
Yes, as most of the tools. Yes.
Yeah, absolutely. Hey, Nenad, any questions for Natalie? Any comments? I didn't loop you in yet.
Yeah, I'm listening, so quite an interesting conversation so far. So don't have anything specific.
Okay. All right. Thanks for that. Appreciate it. Let's see. So I know we're approaching the top of the hour here, but let's see. Is there anything we haven't covered that we'd like to cover here? Do you see, I guess, um, anything that we should be considering that maybe we haven't touched on yet around security, around IoT, and things that maybe IoT builders should think about moving forward with building solutions.
I think from top of my head, the main topic that we haven't touched is really regulation. More and
Oh
more
yeah.
customers, yeah, we just see this across industries where regulation is really putting a lot of the liability on device builders. And we see this, the FBI and NIST and UL is running a few certifications in the IoT space and the labeling program. And really, I think the responsibility and liability for security lies within the builders. And what we used to do, which is, I don't know, patch and have some kind of vulnerability management program, is just not enough anymore. And I think it's a good step forward, but also something the device builders should pay attention to, maybe earlier, because handling regulation could be difficult if you're not prepared for it and don't have the right controls.
Mm-hmm. Yeah, that's a good point. And some of these safety standards and things can take quite a long time to certify and that sort of thing. Have you had some experience with that?
Yes, we constantly help our customers with complying with regulations. Actually, by applying Sternum, you can automatically comply with several
Mm.
regulations and several requirements within specific certifications and regulations. So we have a regulation department in-house inside Sternum. So we constantly have this connection between customers, regulations, requirements, and our product. So this is something that is close to heart for us, and I think one of the values that we provide to our customers is help with that.
Mm. Are there any specific security standards or I guess efforts that you think are useful or that kind of help the builder with building a more secure system? I'm thinking like CSIP or PSA or some of these kinds of security standards that are being developed now by companies like ARM and so forth.
Yeah, I'm not sure if there is any specific one that is exceptionally helpful. I think all of them are still shaping. But we see IEC and FDA and everyone have similarities and some differences. And depending on the industry and the requirement, there are different ones. So I can't really mention one specific.
Yeah, that makes sense. Yeah, there's quite a few. As we've said in previous programs, the nice thing about standards is there's so many to choose from.
Yes, definitely. But in many cases, like if you do things right, then you can apply or comply with many of them at the same time.
Okay. Fantastic. So let's see. As far as a call to action, if you're interested in learning more about sternum, I think the place to go is sternumiot.com. Is that right, Natali?
Absolutely, yes.
Okay. And it's been a real pleasure having you on. Thanks so much for taking the time to talk with us here on IoT Builders. This is recorded, and so we'll have listeners, listening to the recording. So, appreciate you taking the time, and really great conversation. Thanks so much.
Thank you. Thanks for having me, and thanks for the opportunity. It was very enjoyable speaking with you today.
All right. Well, I think that that's the end of our time today. So we will be back next week, I believe. Although I think Alina and myself may be out. It may be up to you, Nenad. But stay tuned for IoT Builders next week. But until then, so long.
Thank you.
Thanks, Natali.
Bye, everybody.
Bye-bye.
Bye-bye.